Hello and welcome to the very first episode of the Gist of It podcast. Before we start with, the first episode and its contents, we obviously want to introduce ourselves first and explain to you what the hell we even want to do in this podcast and what the general idea is. So let's start with an introduction, and I'll ask you to introduce yourself first.
Sure. My name is Nuria. I'm from Barcelona. I studied a bachelor's degree there in informatics engineering. And now, once I finished my bachelor's, I decided I wanted to continue my studies in a master's degree. So I started looking for masters in software engineering. And finally, I ended up coming here in Amsterdam. And now I'm currently doing my master thesis, so I'm almost done.
And my name is Jakob. I was born and raised in Germany, where I also did my bachelor's. And then a year before Nuria came here, I also came here. So we're studying the same master's in the end. I did it part-time, however, which means that I'll now also finish in the same semester. So I'm also finishing off my master thesis for a bit longer already. But also almost a year ago already, I started working as a software engineer in backend for a Dutch online supermarket. And yeah, I like it very much. And finally, sometime after we met, we fell in love with each other, and we're a couple now. So a few weeks back, we decided to do this podcast. I had this idea for quite some time. So this is a real problem I have, and then talking to Nuria, we realized that we both had this. There's a ton of like conference talks, tech talks, whatever you want to call them, out there on YouTube mainly, that mostly are like between half an hour to an hour, or some even 2 hours in length. So I realized that I very much enjoy watching them for the contents, but the problem is that you'll hardly have time, or at least I hardly had time and still don't have, to shave off like 2 hours to sit down and watch a complete video of 2 hours. So really watching someone speak over some slides for 2 hours is pretty much a commitment. So what was our idea here?
The idea is that we watch these talks, conferences for you, and we will summarize them in roughly half the time of the actual conference or talk. So you can decide at the end if you want to still watch the talk itself. And if you don't, then you know the content of the talk and you have more time for yourself. And also you can only listen to us and you don't have to watch a video.
Exactly. So you have your eyes and more time in the end available for other things, but still get all the contents of the talk. So we pick interesting talks for you. So we do a lot of research while watching them, essentially, and summarize them. And also what we do at the end of each episode is give you a short review what we thought about the talk. So recommend certain parts that we found specifically interesting, and also give you a final verdict of we recommend you to watch this either way because it was such an amazing talk, or there was not really anything that our summary didn't contain, for example. And then finally, every talk will be linked in the show notes of each episode, so you can always watch it yourself. That's pretty much it. And then let's start with the first episode, I would say.
Yes, let's do it.
So let's start with our first talk ever. So the first talk today is by Russ Olsen at GOTO Berlin from 2018 with the title Functional Programming in 40 Minutes. So his first starting point that he makes is that functional programming is oftentimes described as being forget everything you know about programming. Myself actually have read this claim a couple of times when reading about this subject, and he claims that it's mystified almost without any need really, because it's actually a quite simple concept. He mainly works, or in his day-to-day job, he explains he works with Clojure. For those of you who don't know, it's a Lisp dialect. Lisp, the oldest functional programming language, Lisp dialect that runs on the Java virtual machine. That's pretty much it. And some of the later examples in the talk are using Clojure, but it wasn't really that much, right?
No.
Okay, then he directly pretty much goes over into saying what are the three main topics of the talk, which are?
What is functional programming?
Exactly.
Then what's it like to be a functional programmer? And does it work?
Yes. Although I thought that, we'll see it now in covering it, but I thought that the latter 2 points he didn't cover that much. If you look at the time allocation, the first one, what is functional programming, was 80% or something.
Yes.
And then the other two were super short.
But also the name of the talk is explaining,
that is fair enough.
Functional programming, so it makes sense.
Yeah. So I guess then let's start with the first one. And there he makes gives an interesting example. He starts explaining things that are very similar in functional programming, kind of debunking this argument that I brought earlier already, that you read oftentimes where just forget everything you know about programming. This is functional programming. And he says that many things are quite similar, right?
Yes. He also makes a parallelism with when you have a program that's becoming very messy and you decide to restructure it, and you never start from scratch, but rather reuse the parts that are working. So that's what he says is that's what functional programming does, just use the parts of traditional programming or object-oriented programming.
I guess imperative. He says object-oriented a couple times.
Yes.
Although, it's pretty new compared to functional programming. For those of you who don't know, Lisp, who I mentioned earlier, which Clojure is based on, is, I think, the second oldest high-level programming language of all times. So functional programming really is no new concept. I think the only older one is Fortran, if I'm not mistaken. So what he means when he says traditional, I think, is imperative programming. So
mainstream. He also uses that word.
That's probably a better term, since indeed functional programming is not super mainstream, or only becomes recently. But indeed. So a few things that he mentions that you just said there are already there in mainstream programming and work well enough, or work fine for everybody. Stuff like things you would directly think about. So conditionals, you do a lot of looping. You just have the same things in functional programming. They work differently, but still there. You have most of the data types, right? Numerical things, booleans, characters, strings, all of that. And he in the end says it's more of a taking things that work well and changing the few things that give you pain, which mainly is, I think his main point is that with mainstream or object-oriented programming, as I said, the distinction is not super nice in the talk, is that it becomes messy over time the older the system gets, by having these types of problems, which functional programming solves to some extent, and that some things work like this, but other times they work like this, and then to reason about the program and have a mental model becomes very difficult, right?
Yes, he also talks about the problems with the possible side effects that your code may have.
Exactly. What's the next thing then he goes into after this? Well, I would say this was really the introduction.
Yeah. Then he talks about how there's a bit of similarity between computer science and mathematics.
Oh, right.
And that the main concept of mathematics that functional programming tries to or borrows, it's this idea of functions, but in the way that it's used in mathematics, just like you have an input and you get an output. There's no ifs, you may have this output or this other one.
Yeah. Yeah.
Very straightforward.
Exactly. I think the main point to summarize it is that you only ever look at the input
Yes.
to compute the output, which everyone can intuitively agree upon. I think that it will always yield the same output then, because if the input stays the same, that's the main point, right? That with the given same input, you'll always generate the same output with the same function, which of course let's say object-oriented programming oftentimes, of course, is not true, since you can have, or you will always have state in your object, for example. So given that a field has a true or false, if you run it twice, it might yield a completely different output, of course.
Yes.
And that's where he makes one first big distinction.
I think his point here is also that this makes your code simpler.
Yes.
Yeah, but this is also when the second change comes.
Exactly. So this first, I saw a pattern of having these three points here that he makes. And the first one indeed now being having pure functions. He says he doesn't really like the word pure because it implies that there's impure functions, but it's kind of true, right? There's functions in what you said in a mathematical sense, that is given input, always same output. And that's what you have in functional programming. And impure ones you'll mostly have in every other non-functional language. Then he goes over to some example of why object-oriented programming is messy, which I found super confusing and not very well chosen. I don't know what you thought about it. So he gave this example of things being convoluted, and then, for example, he shows out of the Ruby documentation where the protected keyword is explained and what the difference is to like having a private method or a protected one. And if I got his point, sort of. It was like a bit messy the way they wrote it, but I didn't really see the connection between that and functional programming.
I think that his point with that example was what he said at the beginning about having a program that then you try to patch to solve some bugs or whatever. Yeah. That's the same that's been done with the programming languages themselves. I cannot do this with this programming language and I want to, then let's try to find a way to kind of...
Yeah, okay. Yeah, I get it. Still, though, I thought the point he was trying to make, which this example he gave very often, is on Thursdays and Fridays it works like this, and the rest of the week it works differently, which is really this explaining this pure functional concept, right? That this is not what you have in functional programming, because on every weekday it'll be the same because the functions are pure. That was a good example, I think, but the other one he brought there, I personally think he could have left out, but oh well, the point got across regardless. Oh, do you want to add something to that? Okay. Then the next thing that he explains is immutability, if I'm not mistaken. So, well, essentially that variable, obviously everyone knows, so you can, in most older languages at least, you can just mutate a variable, override it, would be other term, so just change the value at any given time. Which is not the case in immutability, as the term suggests, of course, which is, well, the second pillar, so to say, next to having pure functions of functional programming that he mentions, right? Yeah, so the upside is pretty clear. I'm not sure what example that he gave there. Oh, right, I think having some data structure x and you pass it into the function f, and then reasoning about what the value of x will be after function f returned.
Yes. And you know that you still have x, and that's it.
Yeah.
And with functional programming, if your idea was to change the value of x, your function should have returned then a copy of x with the values changed or whatever.
Exactly. Because then pretty much exactly he indeed goes over this copying thing, and this I found a very interesting part to talk, although it was not really necessary to understand what functional programming is or to get a clearer insight.
Yeah.
But I like this part very much where he explained these persistent data structures.
Yes.
So essentially, well, the point that he makes is it's nice now if you have an array of 3 numbers and you want to change the first one, the first item, in C, I don't know, you can just override it. And in purely functional programming languages, what you would do is copy the entire list, change, or in one step essentially, copy and modify the first item while leaving the old list in memory where it is, and just having a new one. But of course, then he makes a point, what if you have a list of 1 million items and you only want to change a single one, and then let's say you want to do this 3 times, so you have 4 times the same list of 1 million items and essentially only changed 3 things, which is super ineffective, as I guess everyone can agree, especially memory footprint wise.
Yes.
And then he goes over these persistence data structures, right?
Yes. Which, well, basically he explains that the data structures are stored as a tree with pointers. And then if you want to change only one value, you only have to create a copy of the leaf that contains that value and then the nodes that point to that leaf.
Yeah. But the branch, I think, would be the term. Right? Yeah. So if you want to change, let's say an example, you want to change the first value in the list, you essentially chop off the branch of the existing tree that points to this one, replace whatever value you wanted there, and the rest of the tree you use the pointers from the existing one. Yeah. And the smaller, let's say you chop the list or whatever other data structure, I mean, works with hash maps as well, into leaves. Technically, the more efficient this can be. Of course, you always have some overhead of this copying action. So I guess this is something he didn't really cover. I mean, the reason why for some applications, non-functional programming languages like C is still so popular nowadays, although it's a super old language, is precisely because you can make very efficient code because of this flaw that he points out, right? In some applications, directly mutating something directly in memory is necessary. Otherwise, you'll never achieve speeds that some applications need.
Yes.
Of course, he didn't claim like our functional program, you can use it for everything. He didn't make that claim. No. So fair enough.
I think his point was that functional programming is simpler from probably a maintainability point of view.
Yes. And he also, I think, a couple of times mentioned like applications. So not really things where C would usually be used. I mean, it depends a bit, but yeah. And there he said functional programming can increase indeed ease of reasoning about it. Yes. All right.
Then he talks about the third point, which is that, this is very nice, not having side effects and stuff, but side effects are sometimes necessary to change the state of a database, for example.
Yeah.
So he goes
quickly before that. What is a side effect? Maybe some listeners never heard of the term.
Basically, anything that, I mean, a way to keep a state, I guess.
Yeah. So essentially, let's give an example. The example that he often gave, which I think everyone can immediately understand, is deleting a file somewhere on your hard drive. Yeah. So you call some function, be it in a non-functional language, and it returns you something, but also somewhere in this function it deleted a file, that's why it's called side effect. It at the side has some effect that is not really comprehensible from the outside. By just having a return value of something, you didn't really see from the outside that it also did that. And that's what you want to avoid then with functional programming, right?
Yes, but sometimes you also need it.
Yes. So what solutions does he offer?
He explains that every functional programming language has a way to create a bridge between the pure functional program and the state or the stateful world where side effects happen.
Yeah. He uses this image of a bridge indeed very often between functional world and stateful world. And then I think is the only time really where he uses closure as an example.
Yes.
which is how?
Yeah, he explains that their closure has some kind of data type called atom, or which is the one used to manage like a stateful variable, basically.
Yeah. So I think how it works, he correctly explains it. So it's essentially just a variable or a field in a class that has a value, and you can throw a function at it that has a signature of taking a single argument of the same type of the atom, and then you just apply the function, and you map the function onto the atom, and the atom rewrites the output of the function to itself again. Which also means that you can, of course, apply like 10 different ones in a row and essentially still have state because, well, it updated itself while keeping the functions that you apply purely functional.
Yes.
Then the second thing he covers are agents in Clojure, and there he lost me a bit. The explanation was short and confusing.
Yes. Yeah, I'm not sure. Yeah, he says it's something about managing requests.
Yeah, I think mainly, as I understood it, this is about side effects that would go outside of your system, really, because the only example he ever mentioned was indeed like doing something on the file system or the database access, which of course are external, like compared to some internal variable state. Yeah, mainly as I understood, you add stuff to a queue, functions, pure functions, that then are used in stateful code to apply a commit to a database to update some row or something. But there, his explanation was too short. Like it wasn't really clear. I mean, yeah. If you ask me, he could have either dropped this or made it a bit more accurate. In any case, so that's what I mentioned initially. I think what we both agreed upon, the what is it like to work with it, which was kind of this part. Oh no, this was still the side effects part. Was a bit confusing.
Yeah.
In any case, then he went over
what is it like to be a functional programmer.
Yes. What was his first point?
That it doesn't solve everything. You still have problems that you would have with a more mainstream programming language, such as redundancy, bugs, and bad code in general.
Yeah.
But it has some
niceties.
Yeah, exactly.
I think there he mainly also ties back to this thing in the beginning, that functional programming is not like the silver bullet for everything, because he says that he doesn't like that some other talks or some blog posts on Medium or even some books claim this.
Yeah.
And he indeed makes the points you just mentioned.
Yes. And then he says that when you start using a functional programming language, you think at the beginning it feels confusing and also like a lot of rules, and you feel like you cannot do everything that you would like to do. But then once you get used to it, according to his words, experience, it's that it is easier and faster in a way.
Yeah. I think here we can. Both kind of agree to it. Because this podcast also I think we want to try to combine a bit, like summarizing the talks, but also discussing a bit the topic and bringing in our own experience. I think here this is one where I really felt him, because both of us in our masters had to do a lot of Haskell, which is the prime program. I mean, it's by no means the oldest one, but really the most pure one, or the most where this really lifts the paradigm. And there I really felt him, because starting out with it definitely feels like handcuffs, because if you did any other language before, you know not only because the other language was really easy or anything. Haskell, if you use it a bit, it's not really that difficult, I would say. But to achieve super simple things is convoluted as hell in Haskell.
Yeah. At least initially.
Exactly, initially, which is his point, right?
Yeah, exactly.
So I think you can share this notion that for example, writing to a file. If you use it a bit more, there's a reason why this is so convoluted. Mainly because it is not functional to write to a file, or not pure. But this was the point where I felt him, because starting out with it feels just that you are super slow and work worse than with whatever language you used before, pretty much regardless of what the language was.
Yeah.
What are your thoughts on this?
Yeah, I agree. I think that initially can be, very the handcuffs that he said, like you cannot really move freely. But once you get used to the way you have to think about what you want to do, then it's nice.
Yeah. And then finally, this was everything he said about what it's like to work with it. So it's a bit too short, in my opinion. But then the final point is, does it work? And this is even worse than the previous chapter, or if you can even call it that. Because there he just goes over
library.
The library, the product really of his own company where he's employed, right?
Yeah.
And of course he mentions, because he kind of has to, this is only example, blah, blah. But, well, it's the company he worked. I mean, I didn't feel that it was like annoying advertisement for his company, not at all. I mean, it was a good example. But, this didn't really show me that what he gave as examples there is really true of the entirety of functional programming. So the examples that he gave, where that closure code is like very dense and short, really, like shorter in terms of lines of code than other languages, and that you'll spend most of your day writing functions, right? There was this.
Yes. Yeah.
So he showed like a pie chart of how many how much code of this library is functions, and how much is interfaces, and how much is bridges to stateful world and stuff. And I think it was like 95% functions.
Yes.
But then the argument here, if you look at, I mean, this didn't really give me any better view on this, because this is like a single data point. Like it could be that every other closure library does not have the same layout. So, and
also, does it work? The entire section is already confusing. How do you know it works? And
it's not really.
Yes, because if his point is that the code is simpler or it's easier to maintain, I'm not sure if the amount of functions in the library proves that it works.
No, exactly. I think what personally he should have looked at a bit more is this point of most people probably start out with a non-functional language. Like I think pretty much no one learns program. A few people learn programming with a functional language. It's not very popular, I think. Yeah. At least if you studied at university or something, because you usually start with something non-functional. So I think what he should have covered a bit more is when and how much does this feeling of working with handcuffs, programming with handcuffs goes away? Because I think that's, from our sampling size of 2, that's what most people feel when starting out with it. You see, it's really nice. It has like it has its niceties, but so far I'm still slower than just using something else. And I think that's what he should have covered, because that would have answered to me, does it work? Yeah. So, that might have been more interesting, but oh well. And then he literally ends the talk with yes to that question.
Yeah, I think it works.
Well,
great.
Yeah. So, what's your summary? We overshot a bit already our time limit, but I mean, oh well, first episode. What's your final thoughts on the talk? What did you like? What did you don't like?
I think I like the way he explains why functional programming and I mean, what's the thought process behind it, probably. And I think the main thing that I didn't like is this last part of does it work?
Yeah. I think so too. Especially another thing I really didn't like too much, which is one reason actually why we picked this as for the first episode. He talks. I mean, he doesn't really talk slowly, but he takes very long to get to the point.
Yes.
Which is not necessarily horrible, but the 40 minutes that the talk is long, it's not necessary. I think it could have been shorter. Sometimes he spends 5 minutes on a single slide for not really conveying any more message than he already did in the first minute.
Mm-hmm.
I think the biggest takeaway here indeed is the thing that, tying back what he said in the beginning, and which I liked a lot. So saying functional programming is not really that dissimilar from mainstream imperative procedural programming, but it just takes 80% of the things that are already there and just removes some and adds mainly these 3 other pillars, which are having pure functions, immutability, and no side effects, or at least bridging them.
Yes.
Exactly. And I think that's the biggest takeaway, and also what was interesting. And personally, I like this persistent data structures, but also because I just didn't do it before.
Yeah.
But it was really not detrimental to the talk. I think then our summary is we both like the what is functional programming part, and how is it like to work with it, and does it work was a bit meh.
Yes.
Also because it was too short, I think.
Mm-hmm. I agree.
All right. So that was it for our first episode. We hope you liked it. We'll offer you in the next one some ways, channels to approach us for feedback, since, we'll obviously need your feedback to, improve this format in future episodes. Sadly, currently, there's no way to reach us.
We are working on that.
Exactly. But if you found this on our website, then surely you also found social media or some contact form to reach us. Please do so. We really much, obviously, appreciate your feedback. Tell us what you liked, tell us what you didn't like, what we should not do anymore, what we should do more of. Whatever you want. We're open and happy with any feedback.
Thank you very much for listening to us, and see you in the next episode.
Bye-bye.